In this video lecture, we will go through the nomenclature of substituted aromatic compounds. Firstly, what are aromatic compounds? We have done this before, right? Aromatic compounds, their parent compound is benzene, right? And these are unsaturated compounds, right? And they are called as aromatic. Aroma means odor, right? The earlier compounds that were discovered, they have odor, so that is why they are aromatic. Aromatic is from word aroma, and aroma in Greek means odor, right? So that is why we call these as aromatic compounds, because these compounds have odor, right? Benzene is their parent compound. You can look at this benzene. It consists of 6 carbon atoms, right? That has it has a system of alternate double and single bonds, right? So, and you have 6 CH bonds, right? CH, you can see this, right? 6. So this is a carbocyclic ring because this consists of only carbons, right? Benzene. So this is the parent compound of this is a parent aromatic compound, benzene. You will see benzene in all the aromatic compounds, right? Maybe fused, more than one fused means maybe more than one benzene nucleus or benzene you have in the aromatic compounds, like you have anthracene, phenanthrene, where you have more than one benzene nucleus fused together, right? So what are the derivatives? Now we are looking more into the derivatives of this compound. Derivatives of this compound is obtained by replacing hydrogen with a substituent, right? Here a substituent, like if I replace this hydrogen with methyl group, what I'll get is this compound. Now we'll see how to name this compound, which are derivatives of benzene, right? And in benzene you will see 2 types of compounds, right? 2 types of kind of derivatives where substituent is directly attached to the benzene nucleus. If you look at these substituents are directly attached to the benzene nucleus, right? And there are other compounds where benzene nucleus is attached, where substituent or a functional group is attached to the side chain, right? You may have a side chain like this compound, right? This is your side chain, right? So I may have, if I substitute one of the hydrogen atom of this side chain with some other group, say CH2Cl, right, then this will be treated as the phenyl, right? This benzene nucleus would be treated as phenyl, or what we say is this compound is a aliphatic compound, right? Phenyl derivative of aliphatic compound, right? So remember this, right? If the functional group like the Cl or maybe OH, right, is present in the side chain of benzene ring, right, these are usually named as phenyl derivatives of aliphatic compounds, right? So this would be called as, this is the phenyl derivative of aliphatic compounds, right? How to name this? This would be named as, you have C, right, CH2Cl, right? So this looks like a derivative of methane, CH4, where one hydrogen is replaced with phenyl ring and one is replaced with Cl, right? So how will you name it? This is named as, this compound is named as chloro. You have chloro. This will go as based on the alphabetic order. Chlorine is C, it comes first, chloro. Phenyl comes after, PHENYL. Chlorophenyl, methane, right? This is how you will name it, chlorophenyl methane, right? So what is this? This compound is the phenyl derivative of aliphatic compound. Here aliphatic compound is your methane, right? So here this is named as chlorophenyl methane, right? So this type of compounds are those where substitution occurs at the side chain. Here methyl is the side chain, here substitution occurred with the Cl group, right? And the other type of compounds are these where the substituent is directly attached to the benzene nucleus, here like CH3, OMe, these are benzene derivatives, right? These are the benzene derivatives which are obtained by replacing hydrogen atom with a substituent, right? Now how will you name these compounds? Let's quickly see this. Since this is a substituent, right, and if you recall what we did in as per these rules, right, if you have a substituent, right, if you apply it to this, that we are doing it for the past 2-3 lectures, if you apply this, this is a substituent or a side chain which will go in prefix, right, and word root, these are derivatives of benzene, right? So in place of word root you will put benzene, right, and these will go in prefix because these are substituents or benzene ring or substituents or side chain, and substituents or side chain will go in prefix. So here it would be methyl benzene, this would be methyl benzene, so it is methyl benzene. Toluene is the common name or the trivial name of this compound. Similarly this would be methoxy, methoxy is the substituent or the side chain, and benzene is this benzene nucleus, so this is a derivative of benzene, we call it a methoxybenzene. This is a aminobenzene, right? Similarly this is a substituent, this is a nitrobenzene, this is bromobenzene. So this is how you will name substituted benzene ring, right? Monosubstituted compounds. These are all monosubstituted compounds which are obtained by replacing one hydrogen atom with a substituent. Now let's come to the disubstituted compounds, right? In case of disubstituted compounds, the position of the substituents is defined by numbering. These are substituent, right? Like these two Br, these are substituents. So their position would be defined by numbering. Like here we were numbering the carbon chain, here also now we will be numbering in case of disubstituted and also in case of trisubstituted compounds, right? So we will number the carbon atoms of the ring such that the substituents are located at the lowest number, right? Like here what we were doing in these branched chains, we are numbering this chain so that these side chain get the lowest number, right? Similarly if you have a ring, in place of straight chain if you have a ring, then also you will number the carbon atoms of this ring such that the substituent gets the lowest number, right? For example, I'll number this, I'll number this like this 1 2 3 4. Here this Br gets number 2. If I number it the other way 1 2 3 4 5 6, this Br will get number 6, right? So which is correct? The one that has a lower number. So we will adopt the previous one 1 2 3 4, right? So what would be the name of this compound? What would be the name of this compound if you go by this kind of numbering? 1 2, right? Since these are substituents, as per this it will go in the prefix, right? And what is this? This is benzene. First you write benzene. Since these are substituents, these will go in prefix. So it would be 1 2 bromobenzene, right? It is 1 2 bromobenzene. Now how will you name this? 1 2 3 4 5 6. This, if I number it this way, this substituent has got number 3, this Br has got number 3. If I'll start numbering it in this direction 1 2 3 4 5, it will get number 5, right? So numbering should be such that this substituent will get a lower number, right? So if I number it in this direction, it will get number 3, which is a lower number, and name would be, the substituent will come in prefix, right, as per this. So 1 3 bromo benzene, right? Similarly, if you come look at this, 1 2 3 4 5 6, you may count it from here or from here, right? This will get the same number. So this would be 1 4 dibromo. It should be, I'm sorry, I haven't mentioned dibromo. Since you have two bromines, it should be like, I'm sorry for that, it should be 1 2 dibromo, right? This is how you will name it, 1 2 dibromo. This should be 1 3 dibromo. Now we will name this as 1 4 dibromo benzene, right? Now you will find in your books that these compounds, in addition to 1 2 1 3 1 4, we also call this, if you have substituents at 1 and 2 position, you call it as ortho dibromobenzene, right? This is your ortho dibromobenzene. This is your meta dibromobenzene. This is your para dibromobenzene, right? So this is also this is how also you will name these compounds, right? Because in the trivial system of nomenclature, the term ortho, meta and para are used as prefixes, right, to indicate the relative position, right? So if I am saying ortho, that means the relative position is 1 2. If I am saying meta, that means the relative position of substituent is 1 3. Para, the relative position is 1 4, right? So this would be 1 3 dibromobenzene is named as meta dibromobenzene, right? You denote it with M. If you want to write the name in trivial notation, meta dibromobenzene. This is how you will name it, right? So in case of disubstituted, the most important thing that you need to remember is ortho, meta and para substitution, right? And what does ortho, meta, para shows? It just shows the position of the substituent. Ortho means 1 2, meta means 1 3, para means 1 4, right? And this is a trivial system, right? Now come to the tri-substituted. In case of tri-substituted, common name, you have to first look into the base compound. Whenever you have a tri-substituted aromatic compound, just try to look at the base compound. Here it may be right. If you look at this, the base compound will look like nitrobenzene, like here, right? If you look at this, the base compound is this methoxy, right? Methoxybenzene, right? Or we also call it as anisole. The common name is anisole, right? And this is your aniline. NH2 is aniline, so this would be kind of derivative of aniline, right? This is your phenol, OH. Benzene ring with OH is phenol, right? So just when you have a tri-substituted compound, just try to look at the base compound, right? So for tri and higher substituted benzene derivative, what you will do is the substituent positions on the ring, right, follow the lowest locant rule, right, lowest number rule that we are already doing. In some cases, common names of benzene derivative is taken as the base compound, right? What we will be doing is we will take the common names of the base compound, right? Like I said, this OMe with a benzene ring is anisole, right? And this NH2 with a benzene ring is aniline, right? So these are base compounds, right? So we will name these as kind of the derivatives of base compounds, right? So this compound is the derivative of nitrobenzene, right? And the next one is the derivatives of methoxybenzene, like this, right? And now let's just try to name these compounds. The first compound would be called as it would be called as okay, one thing, the substituent of the base compound is assigned number 1, right? If I take this as chlorobenzene, here the base compound is chlorobenzene, so the carbon compound, the carbon of the base compound would be given number 1. This would be number 1 because this is the carbon of the base compound. Here the base compound is benzene with this Cl, chlorobenzene. So 1, 2, 3, 4. So this would be 1 chloro, right? 2, 4 dinitro. This, which would be a prefix. Since all these are substituents or side chains, it would go in prefix, right? And why chloro will come first, not dinitro? Because we follow alphabetic order. C comes before D, so it would be 1 chloro and 2, 4 dinitrobenzene. Similarly, if you look at this, we will give this, since the carbon of the base compound is this, where you have a substituent. So 1 is this, 2, 3, 4, right? And how will you name it? What would be the name of this compound? It would be, you have a methyl group, a chloro group and a nitro group, right? So you will name it as, if you number it, what numbers will it take, right? Instead of numbering it from here, we'll take the common name, we'll number it from here. We'll take the base compound as this, toluene, right? So this would be taken as the derivative of toluene, 1, 2, 3, 4. So it would be called as 2 chloro 4 nitro, right? Or let's we need to do it in alphabetic order. So it would be 2 chloro, right, 1 methyl and 4 nitro, right? This is the prefix, right? This is a prefix. Why we have done this from this direction numbering? Because if you will do it from this direction, these will get higher numbers, right? So we'll take this, the base compound is nitrobenzene, right? And numbering is let's just do it again, right? So when you number this compound, the base compound is nitrobenzene, benzene with a nitro group, right? Here we have to follow the lowest locant rule, right? That these substituents should get lowest number, right? So I'll start it from here, 1, 2, 3, 4. If I start it from here, 1, 2, 3, 4, this will get number 3 and 4, which are not lowest numbers. So I have to start from this side so that these two get lowest numbers, or this will get, Cl will get lowest number, right? So it's kind of a lowest sum rule that we are following here, right? So it would be 2 chloro 1 methyl 4 nitro, right? I'll just write it over here. It's 2 chloro, right, 1 methyl, right, 4 nitro, right? This is as per the naming convention. So this is how you will write it, right? You make sure you put all the dashes, 2 chloro 1 methyl 4 nitro benzene, right? Now let's look at this compound. How will you name it? You will start counting, numbering from here, because if you start it from here 1, 2, 3, this will get a higher number. So we'll start it from OME 1, 2, right? So we'll name it as, you have to first name the prefix, right, based on the substituents. So it would be like 2 chloro, right, and 4 methyl anisole. This is your anisole compound, right? So you have 2 chloro, right, C comes first, 2-chloro 4-methyl anisole. This benzene with OMe, if you look at this, this is anisole. So this is a anisole derivative, right, which is 2-chloro, right, 2-chloro 4-methyl anisole, right. Numbering is such that Cl will get a lower number. Now let's look at this. This is the derivative of aniline, benzene with NH2, right. So let's see the prefix. Prefix would be, so this will be would be considered as the derivative of aniline, right. So here you have 1 2 3 4, 1 2 3. If I start it from here, this will get a higher number 3, so I'll start it from here, from this point, 1 2 3 4, right. So it would be 4-ethyl 2-methyl. E comes before M, so 4-ethyl 2-methyl aniline, right. 4-ethyl 2-methyl aniline. You have to practice all these so that you can become familiar with how to name these compounds, right. Now if you look at this compound, this is a phenol compound. OH with a benzene ring is phenol, right. So let's number it now, 1 2 3 4, right. So it would be, the name of this compound would be 3,4-dimethyl, right. It would be 3,4-dimethyl phenol, right. 1 2 3 4. So these are methyl groups at 3 and 4, so this would be 3,4-dimethyl phenol, right. Now there are some other type of compounds, like I said earlier, where substitution occurs at the side chain, right. Like we studied this compound before, CH2Cl, right. So this would be chloro compound, right. Chlorophenyl benzene, this kind of compound, right. I'm sorry, chlorophenyl methane, right. So what we will do is, I'm sorry, it's not chlorophenyl benzene, it's phenyl would be considered as the derivative of aliphatic compound, right. So what would be the aliphatic compound here? It's CH4 methane, where one hydrogen atom is replaced with Cl and other hydrogen atom is replaced with phenyl, right. So this compound is a derivative of methane, right. So we will name it as chlorophenyl methane, chlorophenyl methane, right. This is how you will name it. Now let's look at these compounds. Here also you have side chain, right. This side chain, you have a side chain, and this side chain has a functional group attached, right. If the side chain has a functional group attached, then this compound is again it's a phenyl derivative of aliphatic compound, right. So let's see how to name this. You will name this side chain, right, of aliphatic compound, right. So the side chain of this aliphatic compound would be named as, right, it would be, we'll name it like this, 1 2 3 4 5. You have 5 carbon atoms, right? So it would correspond to pentane, right. It would correspond to pentane. We have word root as, because it's an aliphatic compound, so we would be following these rules. Pent, right, 5 carbon compounds, so PENT, right. Now the substituents would correspond to the prefix, right. Substituents will go in prefix. So we have pentane, and at position 2 and 3 you have bromo, right. So 2 3 dibromo, and phenyl is at position 1 of pentane, right? I'll just write it over here, this compound. Right? How will you number it? This here you have Br, here again you have Br, right? So 1, 2, 3, 4, 5. So you have pent, right? Now we will look at the substituents. We have Br, and this phenyl is also considered as a substituent of this pentane, right? Pent, and what is the nature of carbon-carbon bonds, right? It would be, suffix would be ane, right? And these are side chains, so it will go in prefix, right? And we have to follow the naming convention, right? So it would be Br come first, right? So it would be 2,3-dibromo. The one P comes after, 1-phenyl pentane, right? Prefix 2,3-dibromo, right? 1-phenyl pentane, 2,3-dibromo, 1-phenyl pentane. Just again look at this. Whenever you have, I'll repeat one, whenever you have a side chain attached to the benzene nucleus and you have these groups or functional groups attached to the side chain, then this phenyl would be considered as the derivative, right? Right. So let's look into one more compound of same form. So benzene ring attached to alkane with a functional group is considered as a substituent instead of parent, right? So here the benzene ring is a substituent, right? This is not a parent. Here parent is pentane and benzene is a substituent, right? This is counted as a substituent, that is why it goes in prefix, right? So benzene is a substituent. If you look at this compound again, this is a similar compound where you have a side chain in benzene. It consists of 1, 2, 3, 4 carbon atoms. So this is butane, right? So it would be, now this phenyl would be treated as a substituent like OH, right? And a functional group you have which is a aldehyde, right? So the name of this compound will turn out to be, from where we will start counting it. If you remember, we spoke in the previous lecture that if you have a functional group, then this functional group, one would be you have two functional groups, OH and CHO. CHO would be given a higher preference, right? If you remember, we discussed a series in the previous video lecture, and in that series CHO comes before OH, right? CHO comes before OH, so CHO has a higher preference. So this would be the principal functional group and this OH will go in prefix, right? This is what the rule says. If you have two functional groups, one would be principal functional group that has a higher priority, right, based on the series, and the other one would go in prefix. The other functional group will go in prefix while naming this compound, right? So the name of this compound would be 1, 2, 3, 4, right? Its name would be, at fourth carbon atom you have a phenyl, right? And it's first of all it would be BUT, right? Because we have 4 carbon atoms, AN, right? You have single bonds. Then the functional group suffix will come in functional group AL, butanol. And what would be the prefix? Prefix would be 4-phenyl and 3-hydroxy. It would be based on naming alphabetic order. 4-phenyl and 3-hydroxy would be the prefix. So 4-phenyl, 3-hydroxy butanol would be the name, right? 4-phenyl, 3-hydroxy butanol.